What is an operator in quantum mechanics? We can define an operator as an operator is a mathematical rule when we apply or when applied to a kit transform it to another kit. And when it acts on a bra, it transforms it to another bra into another bra. An operator is normally represented by, suppose we have an operator A, which is normally represented by this notation. A is an operator with a cap above it. This is the symbol for an operator. Suppose it's operate on a kit, it will transform it to another kit, psi prime, such that kit psi and psi prime, they belongs to the same space. Similarly, if we apply this operator on a bra, we get another bra, and both these bras, psi and psi prime, belongs to the same space. This is the definition of an operator. Now we have different kinds of operators, but here we will discuss only those which we are dealing in this course. The first kind of operator is unitary operator. It is represented by this I with a cap above it, and once this operator operate on a kit vector, we get the same kit vector. If we apply this unitary operator on a bra, we get the same bra vector. The second kind of operator is called parity operator. And it is represented by the symbol P with a cap above it. And once this parity operator operate on a kit, but remember that the kit or the state vector is a function of position. Then we get, I can write it as P act on a state vector psi, which is a function of R. We get the same function with this notation. H change the position from R to minus R, position vector from R to minus R. We can write it in bracket notation like this, is equal to psi of minus r. This is called parity operator. The another kind of operator is called gradient operator. Gradient operator. A gradient operator is normally represented by this gradient symbol, which is equal to partial by partial x I plus partial by partial yj plus partial by partial k z to k. These are the unit vector. Now if we operate this gradient operator on a state vector psi of r, we get partial by partial x of psi of r I plus partial by partial y of psi of r into j plus partial by partial z psi of r into k. And we have another kind of operator which is called Laplacian operator. And Laplacian operator is represented by this symbol, which is equal to partial square over partial x square plus partial square over partial y square plus partial over partial square over partial z square, or del square over del x square, del square over del y square, del square over del z square. If we operate it on a state vector psi of r, we get del square psi over del x square plus del square psi over del y square plus del square psi over del z square. These are a few kinds of operator which we are dealing again and again in this course. Now, product of operators. How we can deal with products of two or more than two operators of operators. The product of two operators is generally not commute. Suppose we have two operators A and B. Then in general, the product of two operators A and B is not equal to the product of operator B and A. We can say that operator A and B are not commutative. But the product of operator is associative. Product of operator is associative. Suppose we have three operators A, B, C, then the product is such that if we operate B and C first on a vector space, on a state vector, and then we operate A, or if we operate operator C first and then we operate B and A, the result will be the same. And the third property is we may write A operator with power M and A operator with power N. Then we have A operator with power M plus N. The fourth property is when the product of two operator A and B, AB, operate on a kit, say psi, then A will act on the new kit B of psi. Suppose we have two operators A and B such that the product AB operate on the kit psi, then first the operator B operate on the kit. Now this is the new kit, because from this we get psi prime by the definition of operator, because an operator operate on a kit and give a new kit which is psi prime. So B operate on this kit and we get a new kit which is psi prime. So A operate on this new kit which is given here. If four operators, suppose we have four operators and their product is such that A, B, C and D operate on psi, operate on the kit psi or the kit vector psi, then D, operator D acts first, then C, then B, and then A. Now when an operator, the fifth property is when an operator is sandwiched between a bra phi and a kit psi, it yields a complex number. That is, if the operator A is sandwiched between a bra and a kit, we get a complex number. Now this quantity can be purely real or purely imaginary. but in general it's a complex number. But in general it's a complex number. This is all about operator. Thank you.